So for all real numbers x, the function f of x is defined by f of x equals x cubed minus 4x, and the function g of x is defined by g of x equals x to the fourth minus 6x cubed plus 9x squared. So two very large equations. First thought, the Jerry does not want you to graph these equations at all, so we are not going to bother drawing up a coordinate axis here. So column A, the number of points at which the graph of y equals f of x intersects at the x-axis. And column B, the number of points at which y equals g of x does the same. So do not panic, first of all. Think about what the question is asking you for. It's asking for the number of points at which each graph intersects the x-axis. Well, where does a line intersect the x-axis? At the point y equals 0. So we're not going to even use y for the rest of this question. We're just going to say f of x and g of x both equal 0. So for column A, 0 equals x cubed minus 4x. There's an x in each term here, so we can factor out an x to give us x squared minus 4. Now, first thought here, do a little bit of factoring. We note that the numbers eliminate each other in the x coordinate, so that must be 2 plus 2 minus 2, along with the x here. So 0 is equal to x times x plus 2 times x minus 2, which gets us values for x of 0, 2, and negative 2. So this graph f of x intersects the x-axis in 3 places. Now let's take a look at column B. That's x to the fourth minus 6x cubed plus 9x squared equals 0. There's an x squared in each term, so we can factor that out to get us x squared minus 6x plus 9 equals 0. Now we're looking for two numbers which sum to negative 6 and multiply to positive 9, which is going to be minus 3 times an x squared equals 0. So I guess it's about, oops, that's not a 1, that's a 0. Get it in there. So x here is going to equal 0 and 3. So that gives us 3 points for column A, but only 2 points for column B, which means that column A must be the correct answer.